شهر ما طلبت كريم. بس بالله شو اسمه ذكريني بالتاريخ. ذكريني بالتاريخ متى كانت شو اسمه. مم.
Giving problem. There's a code for this group. I could not find this code link. Yes, this one. Yes, can you see my screen?
No.
No?
No.
Not no.
No.
Yes, it's now showing.
Yes, but not all the members are there. Only 3 people or 4. Only 4 people have joined. Now the log. So we will learn about the Verilog. So let us see what is Verilog. I don't know how to get rid of this. Yes, go on. So let us learn a little bit about Verilog. You are already familiar with the assign statement, right? Assign statement is what? It is just to assign some value, like here in this example. Assign my wire equals 1 apostrophe B1 means it is a binary, and this first one means 1 bit before apostrophe. This is 1 bit, then apostrophe, binary type, and the value is 1. So assign statement always build a combination circuit. It doesn't build sequential circuit. So whenever you use assign, it means you are making a combinational circuit. In example 2, you can see how to build a 4x1 multiplexer. You are already familiar with the multiplexer. Multiplexer is what? Depending on the select lines, only one input will be selected and that will be connected to the output. Depending on this select line, if it is 0, 0, first input will be selected, it will be connected to output. 0, 1 next, 1, 0 next, 1, 1 the last one. So it has 4 inputs, so it is called 4x1 multiplexer. And in this one, you can see how to write this module for 4x1 multiplexer in Verilog. There are 2 inputs, select lines, which is 2-bit, and other inputs are the 4 single bit inputs in 0, in 1, in 2, in 3. These are the 4 inputs for the data, and 2-bit select line. And there is just one output, which is 1 bit out. Then using assign
Sorry,
statement.
doctor.
Yes.
Can I record this section because sometimes my internet cut out? So to go through it if the when I finish this lab, can I take it
Mhm.
as a note?
Okay, you can take it if you want.
Thank you, sir.
But you will record, or I don't understand.
Yeah, I start recording now.
Okay, no problem.
Thank you,
But
sir.
I'm afraid that everybody is here or not. Like still only very few people join this. Let me see. It is showing 2 meetings, unfortunately. I don't know in which meeting it is there. Let me disconnect and connect again because 2 meetings are going in parallel. Some people are missing maybe.
نطلع يعني ولا ايه؟
ليل اقسم بالله عظيم.
هذا فعليا الزلمه مشكله.
ضيع وقت على الفاضي يا رجل.
Hello. Yes, all of you are with me.
Yes, we hear you,
Yes.
doctor.
Yes, but I am not sure how many people are with me because Microsoft did this new thing. They created teams again for myself, which is it should not be. So how many people are here? I can't see them.
13.
One is still missing.
One told me that he
There is an icon to show the
electricity.
participants.
So you will.
Which before it was showing on my right hand side.
To the
But
left
now it
of
is
the hang up.
left of the hang up. There's no.
In the middle.
And
Mute.
yesterday I took another section in another course. It was not a problem, but today Microsoft created teams again. I don't know why, and this created problem. Every section has 2 teams, which is confusing.
It is in the middle of the screen. Right with the right. Right. Not the
Show
left. Yes.
participants. Yes. So yes, one is missing, and unfortunately, this is in alphabetical order, not in ID order. So
I know. I know who is missing, teacher.
I can't hear you.
I see. 1 minute. I mean that I know who is missing. Can you hear me, teacher? Number 3. Teacher. Hey.
Again, this is not possible. Not possible. Okay, let us continue. Okay, now.
Teacher,
Yes.
I said I know who's missing. He is Abdurrahman Al-Khurmi. He told me that he don't have electricity, so he will
Abdurrahman
join.
Al-Qurmi.
Yes, I think the serial number 3. Just 3.
Yeah, there is something wrong with his ID. It is already there.
Yes, yes, I know, but he don't have electricity at home, so he can't join us this time.
He can click the link. He doesn't have what?
Electricity. Kahab.
Electricity.
Yes.
Okay, okay. But it means all 14 are added. Yeah, this is due to his problem, right? Okay, no problem.
ايش؟
Okay.
Okay.
So he's living where? Doesn't have electricity. Strange.
He left to Jazan.
Okay. Okay. Okay, let us go to next slide. Before you have seen that assign statement create only combinational circuit, but always statement can build sequential as well as combinational circuit. So today we are going to make, if we are going to make sequential, we will use always. If you are going to make assign, then combinational, but always have this freedom. It can make sequential and combinational both. So let us see other things, and then at the end we will use always block or not. We will see this. Okay, now if statement and case statement cannot be used outside the always block. If you are going to use if or case statement, you must have to use always block, as you have seen in our previous experiments. And assign statement is opposite. It cannot appear within always block. It should be outside always block. So let's see another way of building 4x1 multiplexer. It is same multiplexer as you have seen in the previous slide, but how to write the code using always block, it is like this. Same module name, input output list is same, but as I told you before also, if you are having output in always block, you must have to use this keyword reg. Reg is temporary storage, the register. This is short form of register. Register is a temporary storage device. So here we have to use output reg out, because out is the output used inside the always block. Okay, now the sensitivity list, as I told you, you must have to put a sense, not must, if you just put a star here, then always block will always execute. It will take memory. But if you don't put star there, you put just these variables as a sensitivity list. So what will happen? If any one of this will change, it will change the thing, and it will run always block. So if in 0 change or in 1 change or in 2 change or in 3 change, it will execute always block. So if select line is 0 0, out will get in 0. If select line is 0 1, out will get in 1, and so on. So I hope it is clear. No question, right? So this is another way of writing 4x1 multiplexer using always. Okay, now task 1, which is not possible without using oscilloscope, so you are not supposed to do it, but I need to explain it because it is just one statement, very easy. What is the objective of this task? To observe 100 megahertz clock on oscilloscope. We cannot see it on our light on LED. If we connect this 100 megahertz on LED, it will turn on and off very fast. So we will not recognize it is turning on and off because it is 100 megahertz. Human eye cannot see. So we will observe this on oscilloscope. So module is task 1, one input, one output. Input is system clock. You know that V10, which is 100 megahertz. And then output from P mod pin. You know the P mod, this is P mod. Okay, the extension. So P mod pin is output. And this is one statement only. Assign P mod with system clock. This P mod pin is actually bidirectional. Before we have used for extension switches. That time it was input. Now it is output. System clock is the output from the board. And we are connecting this to assigning this to a P mod pin. So in UCF file, it should be like this. System clock should be assigned V10 and P mod pin to any pin from P mod connector, like this one, or these are all the different addresses of 4 P mod connectors. As you know that there are 4 P mod connectors, A, B, C, D. So you can assign any one of them. So this accessory headers are bidirectional. These can be used as input switches or output lamps, no problem. It can be used for both input, output. So today we are going to use it for output. So task 1 was very simple. Just this small code and run it, and then from P mode connector, from any one of this pin that you assign, you have to connect the oscilloscope probe and you will see the 100 megahertz on oscilloscope screen. I hope everybody use this in any EE course, or at least you have seen this. What is it? Maybe I have some picture here of oscilloscope. Yes, this is the oscilloscope, right? This is the screen of oscilloscope. Here you can see 100 megahertz.
Doctor, I
Yes.
can't see the picture.
You can't see the picture?
No,
You open
just-
the bit
No.
okay, it's right now.
Can you see it?
file.
Yes.
No, I can't. Yes, I
So
can.
no problem. Yes. Okay.
We talk it in the lab of the EE.
Yes. As I said, most of you have done this in E, but maybe computer science students have not seen it. Okay. Now, how to get the slower frequency using this big high frequency 100 megahertz? Let us see. So this is one method, divide by 2 using counters. What is this method, divide by 2? In next lab we will learn another method. Today we are going to use this method, divide by 2 method. Let us see. You have seen this truth table of a 4-bit counter starting from 0, 1, 2, 3 up to 15, right? You have seen this. If you observe this closely, you will see that the least significant bit is changing every new value. See 0, 1, 0, 1, 0, 1, 0, 1. It is changing every new value. It is alternating between 0, 1. Next to least significant bit, it is changing every 2 values. First 2 values 0, next 2 values 1. Next 2 values 0, next 2 values 1, and so on. So it is alternating every 2 values. So its frequency is half than A. A is changing every bit, B is changing every 2 values. A is changing every new value, and B is changing every new 2 values. And C, you can see the third bit, it is changing after every 4 values, right? And D is after every 8 values. So the frequency of B is half of A. frequency of C is half of B, and frequency of D is half of C, and so on. If we have fifth bit, it will be half of D, and so on, right? So if you look at the counters like this, these are counters. You can say that if first counter is applied with clock pulse like this frequency, the output of the first counter will be like this, half frequency of QA. And this is A, B, C, D. Q is the output of these flip-flops or counters, you can say. As we already discussed, Q's are outputs and D's are inputs. So you can see Q is half of the original clock frequency. QB is half of QA, QC is half of QB, and QD is half of QC, and so on. So if you generalize it, it will be like this. If this is our clock frequency, then the first bit, the least significant bit, Q0 for example, will be divided by 2 of the original clock frequency. Then Q1, it is half of Q0. Q2, half of Q1, and so on. So if we generalize it, it will be like this. Qn will be the frequency, will be the 2 to power n plus 1. Right? Why n plus 1? Because for Q0, it was divided by 2 to power 1. For Q1, it was divided by 2 to power 2, which is actually divided by 4, right? And so on. So if you generalize it, then Qn stage will have divided by 2 to power n plus 1 frequency. Right? Is it clear? So
Yes.
if we want 1 Hertz frequency, as you know that what is 1 Hertz frequency? 1 cycle per second, which is very convenient for human eye. 1 Hertz frequency is very convenient for human eye. We can see this frequency very easily. So if we want to get 1 Hertz, we want to see what is the value of n. Right? We have to find the value of n. Are you people with me?
Yes, yes.
Yes, really.
Yes.
Yes.
Yes, I am not sure. Are you with me?
Yes, yes.
Okay.
Yes, we
So
do.
please speak a little loudly.
Yeah, yes, doctor, with
Yes.
you.
We hear you.
But please, guys, I'm
Your voice is
recording.
very dim.
I'm recording the
Can
lab.
you speak
No
loudly,
one.
please?
I'm recording now the lab. No one turn it off, please. There's some guys dismiss the recording, so please no one dismiss the recording.
Okay. So if we want to find what stage, like what is n, what is the stage to get 1 Hertz frequency, we can do this. Desired frequency equals to original frequency, which is 100 megahertz, divided by 2 to power n plus 1. So if we put this original frequency 100 megahertz, we'll find n will be 26. 2 to power n plus 1 will be 27, so n will be 26, right? So we find that n is 26. So in task 2, we will build a counter circuit of 26 bits, right? 26 bits. Because we want to get 1 Hertz frequency, right? But to tell you that 1 Hertz is not power of 2. So we'll not get exactly 1 Hertz. It will be approximately 1 Hertz. Okay. So we will write a code in Verilog to make a counter of 27 bits, because n is equal to 26 means it will start from 0. So it will be 27 bits from 0 to 26. So this is the code for the counter. And what is it? Module name is counter, and hash parameter width is equal to 27. Why we have this? It is same as we describe constant in other languages in the beginning at the top. Why? Because we don't have to go through the whole code to find where we mention this width. Next time maybe we need a smaller counter, 20-bit counter. We'll just change here 20. That's all. If we need bigger counter, 30-bit or 40-bit, we'll just change the width here. We'll not disturb the whole code. So here, this is the width of the parameter, width of the counter, which is declared as parameter, 27 bits. There is input clock. Always there is a reset for sequential circuit, as you know that. And this is circuit enable, which name is enable here. And there is output. How many bits are output? Width minus 1. Width minus 1 means 26 to 0. So 27-bit output. Right? Width minus 1 will be what? Width is 27. So width minus 1 will be 26 colon 0. And then we will assign this count to count reg. Why? Because we are going to use always here, always block. So for this one, we are using count reg. Okay, and see here in the always block, the sensitivity list is just a positive edge of the clock. Whenever there is a positive edge of the clock, it will run this always block. It will execute always block. So here we have in this always block begin if reset. If there is a reset signal active, make the counter 0. Else if enable means if reset is not there and enable is there, then increment the counter. Right? If it is 0, it will be 1. If it is 1, it will be 2, and so on. So it will go up to our required value. Because it is 27 bits, so it will be 27 ones. Right? So this is just to write a counter code of 27 bits. Still, it is not for 1 Hertz clock. So for 1 Hertz clock, we have to do this thing. This is our module task 2, in which we have these things. Input is system clock, reset, and enable, and output is 1 Hertz. So we are using same counter. This counter, see this module counter. We are calling this here counter, and there is a parameter 27. So we are calling it like this hash 27 due to this hash parameter. We have to call it like this. Then this is a name for this counter C1. Then system clock. These are the inputs: clock, reset, enable, and output count. So system clock, reset, enable, and output count. And assign 1 Hertz to count 26. This square bracket means the 26th bit of the count. Right? This is 27-bit count, right? Starting from 0 to 26. So count 26 means the 26th bit, the most significant bit, which will be the slowest frequency. And we calculated it. This will be approximately 1 Hertz. So in UCF file, system clock will be V10, reset will be the push button, enable will be the slide switch, and 1 Hertz should be LED.
How can we assign the push buttons and how can we know the value T11
You have to assign this in UCF file.
like this?
System clock V10, reset
Yes.
any push button, enable any slide switch, 1 Hertz any LED in the
Yes, I know,
UCF
but
file.
yes,
You have to
but
assign it.
we don't have the FPGA board. How can we know the like V10?
Unfortunately, I cannot listen your voice. Yes, can you speak?
I mean, and we don't have the FPGA board. How can we know the what
Yes, you don't have FPGA board,
push
so
buttons
you have
and
to
the
simulate it and just assign this. I will just grade your project. I will see this assignment is correct or not. Yes, unfortunately, you don't have FPGA board, so we will not run it on FPGA. I will just check your UCF file if it is correct or not.
Yes, I know, but how, we have. Okay.
He means the ports
Mm.
like T11, T5.
Yes, how can we know this could differentiate between the push button, and slide switch, and the lid? Yes, the lid.
You already have these in my PowerPoints. We have all these in our PowerPoint introduction to FPGA. There are slides which are showing what are the addresses for the 8 LEDs, what are the addresses for 8 switches, what are the addresses of 5 push buttons. It is there. And system
Okay.
clock is always V10.
System clock. Okay, like in.
It is always V10. Fix. Okay.
Doctor,
Task 3 is yes.
I have a question. What does the positive edge mean in the always sensitivity
Yes,
sensitivities
positive
list?
edge. I will show you. This is negative edge. Down arrow. This is negative edge. Positive edge is this, going from 0
Okay.
to 1.
Okay.
Right? Whenever there is a positive edge going from 0 to 1, it will change. So positive edge is this. Even you can, if you want to use negative edge, it will be NEG edge, neg edge.
Okay.
Instead of positive edge, negative edge, right?
And it will be
But
the same, yes.
keep this as positive edge.
Okay.
Maybe, I don't know, it will create any problem for you.
Okay.
And we are not in front of each other, so maybe I cannot solve that.
Okay.
So just use as it is given here. So task 3, there are total 3 tasks. First task, you can skip even, and that is for oscilloscope. You cannot do it. You can just write the code for that. And by the way, this will be the top module for task 2. This will not be the top module, right? This is the top module where you are calling this counter. Okay, task 3. This is build a frequency selector circuit. There is a 4x1 multiplexer with 2 select lines, and it is having 4 different frequencies from the counter. You know that every bit has a different frequency, right? 26 is almost 1 hertz. 25 is different. 24 is different. 23 is different. So here we have a multiplexer with 2 select lines. So it will get 4 different frequencies, and this out is connected to an LED. And depending on these 2 select lines, which will be the switches, 2 switches, S0, S1, you have to, it will show different frequencies. All the 4 frequencies, it can show one by one depending on the 2 select lines. So how to do this? This is a little bit work from you. So module name is task 3. Input is system clock. Reset enable, same thing as task 2. Only the difference is what? Here we have to write the code for multiplexer also. The 4 outputs of these 4 outputs of the counter are connected to 4 inputs of the multiplexer. So there are 2 different ways. Either assign statement, LED is the output of the multiplexer. LED is equal to this question mark. I hope you already know question mark. I explained it before and today again. Question mark means if this is true, it will go to this first value. If it is false, it will go to the next value after the colon. This is colon, 2 dots, right? And then if this is true, it will go to this. If this is not true, it will go after the colon. So you just have to fill these boxes. Then the code will be complete. Or if you don't like a assign statement, you like always block, then you have to fill these boxes. And these are in the first 2 slides. In this experiment PowerPoint, you will find this there. So you just have to complete this code and task 3 will be complete. Okay. Now, as you know that your lab notebook is not required because of this online, you just have to do this in one page document or Word document and send me with the project. Question 1, you have to answer. Why do we need to divide higher frequency to a slower frequency? Very simple answer, and I already gave you this answer. And then question 2, draw this table and write the value of n. N is what? This is n. 23, 24, 25, 26, right? You know that this is n as we have seen here. N, right? N 26. N 26 is approximately 1 hertz.
Excuse me, doctor. Can you explain in again?
N is like the value we found with the formula. Here you can see, I will show you here. This is n. The nth bit. This is 0th bit, first bit, second bit. This is nth bit. Nth bit will be a different frequency than n minus 1. Understand? N minus 2 will be different. N minus 3 will be different. So here we have this thing. Like this is n. This is n minus 1. This is n minus 2. This is n minus 3. So this is 26, 25, 24, 23. So in this table, you have to write this. In what order? Highest to lowest frequency. Which one is the highest frequency? You have to write the value of n here. And here you have to write the lowest frequency. And the select lines. And what will be the value of the select line here? S1, S0 to get 23. What will be the value of S1, S0 to get 24? And so on, right? Understand? So
Sir.
here
Yes,
you have
sir.
to write the values of the two select lines. And here you have to get the values of this, like 1 hertz approximately. Then the next will be what? And third and fourth, whatever. But as I told you, this is approximate value. So you have to find the actual frequency by the calculations. What calculations? Here. This one. Desired frequency is equal to original frequency. And here you have to change the value of n. Put n 26 and see what is the frequency you get. Put n 25 and see what frequency you get. Right? Understand? So you have to find the actual frequencies. For actual frequencies. You will see that as you calculate, it will be more away from the original frequency that you are assuming. Like 1 hertz will be like 0.75 hertz or 0.74 something hertz. Right? So you have to fill this table in A4 document and you have to send me this. And the deadline is tonight, 12 o'clock for the project. And how to send the project? And let me see. For example, I already announced it at Blackboard how to do this. Go to project, clean up project files, click OK, and then zip the folder, whole folder, zip it, or RAR, whatever compressed tool you have, and send me at the Blackboard. I will make an assignment for this. You have to submit at the Blackboard.
Doctor, how do we submit the three
At the
tasks?
Blackboard. I will open this in the assignment of Blackboard. You have to zip the folder along with the Word file and submit.
Do we give 3 different projects?
Can you speak loudly, please?
Can we, or do we need to give 3 different projects?
Can you give what?
Do we need to give 3 different projects?
3 different? No, in one project, you are not going to compile it and not going to download this in FPGA. So just one project having 3 tasks. Task 1, 2, 3. Even leave task 1, task 2 and 3.
Just 2 files, task 1, task 2.
No. In one project, there will be 2 Verilog files. Not 2,
Yes.
actually 3. Because for task 2, there are 2 Verilog files. Right?
Hmm.
But it
Counter
should be,
and task 2.
yes. So one project only, not 3 projects.
Doctor,
Right?
Yes.
the clock for the FPGA, is it 100 megahertz?
Yes.
Meaning 1024 or 1000?
No. It is 100 megahertz. 100 into 10 to power 6 hertz. Right? Any other question?
There will be no report, isn't it?
Sorry?
There will be no report. This
No report, just one page, which is asked in the last slide of PowerPoint.
Yeah, 2 question and tables.
One question and one table.
Yeah, thank you.
Should we put
Okay, one
Doctor, what
question,
about
question 2 is a
the
table.
previous task? The previous experiment.
Right? So, should we discontinue?
Doctor,
If you have any
where should
problem,
the
send
Word
me
file?
email. Right?
Where should we put the Word file?
Actually, I'm going for prayer now. I will be back after 10-15 minutes. And in the meantime, I will see what is the problem with the teams, why they created another team for me. Right? So I'm going for prayer now. So after prayer, I will again make it available or keep it as it is. Okay, I'm going for prayer now.
Okay.
شباب، سؤال بالله، الحين احنا اللي لازم نسويه اللي هو تاسك 2 تاسك 1 بس، ما
2 و 3.
عفوا 2 و 3. ام سوري.
ما يبينا نعطيه الكود حق تاسك 1 في فيرولوج ولا
لا تاسك 1 لا.
كلش ما سوى فيه شيء ابدا.
طب ملف الوورد وين نحطه؟
قال لك هو حيفتح اول شيء بالبلاك بورد سبمشن وحتسبمت قبل 12 بالليل.
يعني تحط ملف الرار وملف الوورد كل واحد لحاله ولا مع بعض؟
ما ادري، اتوقع لازم كله تسوي له زب، كله داخل الزب فايل. that's my thinking. شو فايدة اني اسوي زب بس للكود؟
لأنه ذاك بروجكت.
اوكي I don't know. بس يرجع الحين بعد 15 دقيقة اسأله.